So I alluded to this in previous chapters, but let's take a detailed look at what happens when a program instantiates an object and stores its address in a reference variable. Space is allocated in memory for the car reference variable, and the car reference variable will hold the address of an object, but since there is no object created for it yet, it doesn't hold a legitimate address. Space is allocated in memory for a new car object here. The address of the allocated space is then assigned to the car variable. The car variable's value, and that's the address of the car object, is used to find the car object in memory. And then in this case, 2008 can be stored in the car object's year variable. Note that for this assignment to work, we're making the simplifying assumption that the year is a public instance variable, as opposed to a private instance variable. And you should remember from our discussion of object modifiers with the how public and private changes how you can access a member variable. And here's what this looks like if we were to visualize the memory allocation. First, we create the car variable. Okay? And as you can see here, we don't know what its memory is. There is just garbage in there, right? So then we're going to create a new car object and store the reference to that object in the car variable. So here we are setting aside this block of memory for the car object. And then we are going to store that location in the car variable, right? And so that's what this is doing right here, line 2. Then we are going to update the memory location that the year variable points to with the new value of 2008. So this year value right here is a certain offset from this 1062, but all of that is, we don't have to worry about that. That's handled by the compiler and the operating system. All we have to know is to tell, hey, we're going to store 2008 in this year variable. The compiler is going to say, okay, I know that is maybe 24 bytes off of 10,062, so we're going to say 1,000 and, what is that, 86? All right, so at memory location 1086, store 2008. Again, that's just the theory. You don't have to know that. You just have to know how the assignment and the variables work together. Okay? And understanding how the objects are created, stored, and accessed at a lower level is really critical to helping you understand how your program will act and assist in troubleshooting bugs in your programs. So let's talk about assigning a reference. The result of assigning one reference to another is that both reference variables then point to the same object. And so again, here, if you take a look, we are creating a new car object, right? So we've got this, just like in our previous slide, we've got the start of the car object. And we're going to create it, and the operating system is going to come back and say, okay, this is where that memory location is, and we're going to store that in car 1. And here we're assigning a memory location to the car 1 variable, which is created and stored on the stack. So the actual object is stored on the heap, and it's got a memory location, and we're going to store it on the stack because that's how the program is going to get executed. We then create a second car variable, in this case car 2, and then we're going to assign the memory location of car 2 to it. Car 1. Okay, and then we're updating car 1's year with 2008, right? And with both reference variables pointing to the same object, if the object is updated by one of the reference variables, then the other reference variable will notice the change when it attempts to access the object. So here you can see that this probably wasn't the intended functionality, where we set car 1's year to 2008, and we thought we were setting car 2's year to 1979, but since both of our car objects, so this is car 1 right here, and this is car 2, right? Because those are our variables and they're storing an address, but they both store the same address. So they're pointing to the same object, and so when we update car 2's variable to 1979, we're just overwriting this 2008, and putting 1979 there instead. So it's really important that you understand how this operates, that you can't just create an object and make a copy like this, because you're not making a copy. You're just telling it that, hey, we're aliases. We are pointing to the same object. So let's suppose you want to create two car objects that are the same except for the color. So your plan is to first create the car, right? And then copy the first car to the second car, and then update the second car's color instance variable, right? Will this code accomplish that? No, it won't. The problem with the previous slide's code is that the Stacy car equal John car statement shown here causes the two references to point to the same single car object. Just like we saw in the previous slides, right? We created a single car. Right here, we've only created one car. Thus, John car's color becomes peach, and that's what's not intended. So here's another diagram to help you kind of visualize what's going on. It's similar, but I hope it reinforces what's going on. Is we created a single car object, and we set all of these attributes, right? And then we made Stacy's car as a variable, and we just assigned it a reference to John's car. So they both point to the same thing. So if you want to make a copy of a reference variable, you should not assign the reference to another reference. Instead, you should just instantiate a new object for the second reference, and then assign the two objects' instance variables one at a time, like this. So you can see here we create two separate car objects, 1 and 2, right? John car and Stacy car, and then we copy element-wise each of the attributes. So we copy make down, and then we copy year down, and then we copy color down, okay? And it sounds kind of like, well, hey, that's a lot of code to make a copy. And we'll say, yeah, it is. And so there's smarter and better ways to do that. And we're going to take a look at that. So before we get to copying an object, we're going to take a little detour and talk about testing objects for equality. And as I've mentioned before, when comparing two reference variables with equals equals, you would expect this operator right here to return true if the data in the two reference variables were the same. Unfortunately, that's not how things work. For this example, this is going to print out that they are different, because the car 1 and car 2 equals car 2 expression returns false. But why? Well, because of this right here. Okay? Each of these new operators is going to set aside memory space for a separate car object, right? Car 1, car 2. So when it's comparing these two objects, it's going to say, no, they are not the same. They do not occupy the same memory space. So that's why this doesn't work. The equals equals operator returns true if the two reference variables point to the same object, i.e. the two reference variables contain the same address. So for this example, what does this code fragment print? Hopefully you figured out that it's going to print out that they're the same, because this is just like the first cases when we were trying to make a copy of the car. We only created one copy of the car. So car 1 and car 2, right, they both point to the same object. So they're the same. They occupy the same memory space. All right, that's 10101, in case you're wondering. And so with them pointing to the same memory location, this is going to evaluate to true, whereas previously we had two new operators, two separate objects, and it returned false because they were pointing to different memory locations. So when dealing with objects, obviously the equals equals operator is not good enough. But you will use it for primitives though, so don't throw it away just yet. But you'll usually want to compare the contents of two objects rather than just whether or not they point to the same place in memory. And to do that, you're going to need to have an equals operator, okay, for objects. And that will, with that method, you will be able to compare two objects to each other. But before we can compare two objects using the dot equals method, we need to discuss passing references as arguments first. So let's take a look at that. So suppose you pass a reference variable to a method, and inside the method you update the reference variable's instance variables. What happens? Remember that a reference variable holds the address of an object, not the object itself. So in passing a reference variable argument to a method, a copy of that object's address, not the copy of the object itself, is passed to the method and stored in the method's parameter. Okay? So remember, we're copying the memory address and giving it to the new method. And since the parameter and the argument hold the same address value, they're going to point to the same object. Thus, if one of the parameters instance variables is updated, then the update will simultaneously update the argument's instance variable in the calling module. Whew, that is a lot of text, and you're probably reading it going, I don't understand any of that, or this is very confusing. And I did this for a reason. Yes, it is. If you just read it like this, it is. But we're going to take a look at an example that hopefully will clarify all of this. So here we're going to take a look at two classes, the person driver and the person class. And the person class is very simple. All it has is a private variable called name, and then we have a setter method, and then we also have a getter method for that name. So just those two methods. And then finally we also have a public method called swap person. And you'll see as an argument it takes a person object. And so we have a person object, and it's going to have the alias or the variable name other person. So we create a temporary string, and we get the other person's name, and we store that in temp. And then we set the other person's name to this person's name. So say I'm Bob, and I want to swap my name with somebody else. Well, I'm going to call swap person on me, and I'm going to get Bob's name, and I'm going to store their name as mine, and then I'm going to set my name as the temp variable. So this pattern right here, this swapping algorithm, is very common, and you're going to see this used very often. Whenever you need to swap two things, you create a temporary variable, you assign one thing to the temp, you copy whatever it is you want into that thing, and then you use the temp variable to update the last item. Okay, so you're going to see this over and over and over again, so you'll get to know it really well. And that's all the person class is. That's all there is to it. But the driver class, you can see we create two people here, and we set their names to Jonathan and Benji, right? And then we're going to print out their name and the second person's name. And then we're going to swap the person, right? And we're going to print the person's name and the second person's name, okay? We're going to get to the swap to in a minute, but it's not going to work, okay? And we're going to show you why. But for now, let's just go ahead and compile these and take a look at just this first part. In fact, I'm going to comment out this part so it doesn't execute, right? So hold on here. Oops. Helps if I do the right order. Okay, so that's commented out, so we're going to go ahead and compile it. Okay, compiled successfully. We're going to compile our person. All right, now we're going to go ahead and run our driver, right? So there you can see, plain as day, that we printed out person 1's name and then person 2's name, and then we followed it up by swapping them, and we printed out Benji and Jonathan. All right, so let's take a look at the swap to method down here. So we have this static swap to method that's going to take in person 1 and person 2, And then now let's run that. Okay, so let's get rid of our comments. And we're going to recompile. And we're going to rerun it. All right, so now we ran the swap2 method, and it should have swapped their names back to original, right? Because they were already swapped, and then we're calling swap2 here. So it should have swapped them, but it didn't. It kept them the same. Well, what's up with that? We did the same thing. We got this algorithm here where we're swapping, you know, person 1 and person 2. Shouldn't their names have swapped as well? Well, let's take a look at why not. So I'm going to break this down line by line so you can see what's happening with this particular swap algorithm and why it doesn't work. Okay, the first one did, the second one didn't. So the moral of the story is you have to be careful with passing references, right? So we had our main program, and in it we had two people, person 1 and person 2, and it got assigned a memory location of somewhere on the stack, so stack 10 and stack 20. And its value is pointing to the new people, right? Because we created a new person, so it's pointing to the heap 10 and the heap 20, right? Well, then we call swap2, all right? So you can see here we're passing in person 1 and person 2, and its memory location, it creates a new memory location because person 1 is a new variable, right? It's a temporary variable for just this function or this method, right? So P1, person 1, gets this new memory location of S30, and person 2 gets this new memory location of S40. But when we pass it in using this swap method right here, right, those variables are going to be, these P1 and P2 are going to be assigned the memory locations of person 1 and person 2, right? So we're going to create this new person called temp, right? And we're going to assign it to P1, right? So P1 now stores H10, so it stores the memory address 10 on the heap. So you can see person 1 is the same, person P1 and person 1 and temp all point to the same object. Then we are setting P2's address to P1. So right now P2's memory address is H20, and so P1 is now going to equal H20, right? Temp is still set to H10, P1 now equals P2. Well, then we assign temp's value to P2, and so P2 now equals 10. So we've effectively swapped these two memory locations, right? But notice what didn't happen. These values over here never changed. So we didn't actually swap person 1 and person 2. All we did was swap P1 and P2. So this is kind of a tricky situation, and it's going to be, I'm sure you'll probably have bugs in the future where you think like, what, I'm copying this, I'm doing all this stuff right? You got to remember this little vignette here, that when you pass in memory locations, you're not changing the memory locations here. You're passing in a copy of the address where those things are stored. Okay? So be very, very careful with this. I'm sure it'll bite you in the butt at some point, but you can't say that I didn't warn you. So sometimes you'll want to have an object's attribute to be fixed or constant. So to make it constant, you just use the final modifier, as in this example right here. And here you can see we're declaring a string object called name, and we've added the final modifier to it. So this is what we're adding in right here, right? And so even though a person can change their name, yeah, it's fairly common in this kind of situation that they wouldn't, so you would go ahead and use final for that attribute. When you use final for a variable that's declared but not initialized at the top of the class, you're creating an instance named constant, or we refer to it as a instance constant. But if you initialize it, it would be the same for every object. it's still an instance constant because it's not static, but we'll get into that into the next section. But what you need to know is that see the difference here is where we assign it. Here we're doing it in the constructor versus here we're just doing it at the top of the class. And it's legal to assign a value to an instance constant only one time as part of the attribute's declaration or within the object's constructor. Because the final modifier keeps a named constant from being changed after it's initialized, it's safe to make the instance constant public. This makes it easy to determine the value of an object's permanent attributes. So you could just use this syntax like this right here, where if this was, say, person's name was, say, Emily, right? It'd be Emily.name, right? Or we'll say P1.name, and it's all caps, right? So you can access it like this because it's public, and you can't change it, so it's safe. So you don't necessarily have to worry about encapsulation unless it's some kind of value that you want hidden from prying eyes and other applications. So the biggest thing to notice here with these two different versions is that with the one on the left, this one here, this is the proper way to do it. If you do this, every single person object that you create is going to have the name Karen, right? So if you initialize it at the top of your class, everything's going to have the same name. Where in this method over here, we are assigning it in the constructor, so it's not going to get actually assigned until you create the object and pass in a name parameter. So that's the key here, difference between these two methods. So let's take a look at this in practice. We've got this ghost class here, and it's got a, well, let me get rid of this because this was not part of it. So here we have a final string called name, and we have an int saying last seen, okay? And we have a constructor where we're going to create a ghost, passing in a name and a last seen, and assigning those together. And then we just got a simple display function that's just going to print out the name and when it was last seen. All right, pretty basic, pretty self-explanatory, okay? So we also have a driver class, which is just going to create a ghost called Kate and a ghost called Dorothy, and we're going to print out ghost 1's name. And you can see how we can access this named constant, this instance constant, just by using the object name, the dot operator, and then the attribute. So if we go ahead and run this, you will see here, we ran it, and it prints out Kate Morgan, and then you can see here with ghost2.display, it prints out this whole bit right here because that's what it was programmed to do, right? Last seen, last sighting, whatever. Okay, so what happens if you try to change the name after you run it? Okay, well, let's try that. Let's say, you know what, we're going to do, let's say ghost1.name is equal to Corey W. Oops, helps so I can type. Corey W, right? Great name. Okay, if we compile it, got an error. Tool completed with exit code 1. Look at that error. Cannot assign the value to final variable name. Right there. So the compiler yells at us and it tells us exactly what we're doing wrong. It says, hey, dummy, it's a final variable. You can't change its value after you've already set it. Okay? So you're pretty safe there. You'll find out when you're doing something wrong because the compiler will tell you, but it's important that you understand why.